Welcome back, grade 10s. So someone asked me to do these questions, which are the exponential expressions. So we have to solve now this one, and then I'll do maybe example 2 and example number 3. So this one we are given 2 to the power of x minus 2 to the power of x multiplied by 2 to the power of 2. Then on your denominator, you have 2 to the power of x multiplied by 2 minus 2 to the power of x. So for these types of questions, if you are given these exponential expressions with a subtraction or sometimes an addition in between the terms, then you need to know that you have to look for the common factor. Always there will be a common factor. If there is a plus or a subtraction between the terms, this is term 1, this is term 2. All these 2x to the power of x times 2 to the power of 2 is one term. Also on your denominator, this 2 to the power of x multiplied by 2 is one term. This 2x is one term. Now we have to take out now a common factor. Let's look for a common factor. So the common factor, if you look now at these two terms, I said this is one term and this is one term. This is one term and, this is one term and this one is one term. So you have two terms in the numerator and two terms in the denominator. So we have to take out a common factor now in the numerator. You can see the common factor is 2 to the power of x. So if you take out now 2 to the power of x there, you'll be left with the 1 minus. If you take out 2 to the power of x, you'll be left with 2 to the power of 2 bracket all over. Now you look at the denominator. If you take out the 2 to the power of x, this is another common factor. You'll be left now with this 2 only minus. If you take out this 2 to the power of x, you'll be left with the 1 there. Okay, yeah, you're left with the 1 because you take out this common factor, which is 2 to the power of x. Now you can see that 2 to the power of x and 2 to the power of x cancels. So you are left now with this 1 minus 2 to the power of 2, that's a 4. The denominator is 2 minus 1, which is a 1. So 1 minus 4, that's a negative 3 over 1. So negative 3 divided by 1, that is negative 3. Okay, so I have a second example here. So let's look at this one. Here you are given on the numerator 3 to the power 2x plus 1 minus 4 times 3 to the power of 2x. On the denominator, you have 3 to the power of 2x plus 2. So before we solve this one, let's remind each other of the laws of exponents. You know, the laws of exponents says if, for example, you have something like 3 to the power of 2 multiplied by 3 to the power of 1. So we normally say that if the bases are the same, then we need to add the exponents. Now I was going to have 3 to the power 2 plus 1. So it's like now you are given the reverse of it. It's like they gave you this 3. It's like they gave you 3, 2 plus 1. So that means that if I gave you 3, 2 plus 1, you can say now these two exponents, which is 2 and 1, have the same base, which is 3. So it's like you have now 3 to the power of 2 times 3 to the power of 1. Because of now two exponents have the same base. If two exponents have the same base, you can expand it to 3 to the power of 2 times 3 to the power of 1. Alternatively, if they gave you like something 3 to the power of 2 times 3 to the power of 1, you can take the base to add your exponents. Okay, so now let us go back to our question. I'm trying to find out now. My pointer is disturbing me a little bit. Okay, let me just pause the video and then I'm going to come back to it. Oh, okay, so let me redo it here. So whenever you see a subtraction or a addition, then you know that you have to take a common factor. But before you do so, you need now to expand all of this. So I said now a few minutes ago that if you have now one base, which is 3, and two exponents, you can actually say this is 3 to the power 2x multiplied by 3 to the power 1, because these two exponents both have the same base, which is 3. Then you minus, here we have a 4 multiplied by 3 to the power 2x. Then we go to the denominator. You can say here we have 3 2x multiplied by 3 to the power of 2. Yeah, so let's look now. What is the common factor here? You can see now 3 to the power of 2x. Again, in this one, we have 3 to the power of 2x. Again, here, we have 3 to the power of 2x. So we have to take out now this common factor, which is 3 to the power of 2x. So remember, this is one term. So if you take 3 to the power of 2x there, you'll be left with that 3 to the power of 1. Minus, if you take this 3 to the power of 2x, you'll be left with that 4. Now on your denominator, you just have one term. So if you take out 3 to the power of 2x, you'll still be left with that 3 to the power of 2. So you know that the common factor cancels, then you are left there with 3 minus 4. Now 3 minus 4 is negative 1 over, now 3 to the power of 2, that is 3 to the power of 2, that's a 9. So your final answer now is negative 1 over 9. Yeah, that is the answer that you are left there. So that is number 2. Now let's do the last example, which is example number 3. Okay, so in our last example, we have now this expression, which is an exponential expression. It says 45 to the power of x plus 1 multiplied by 9 to the power of x minus 2 divided by 9 to the power of 2x multiplied by 5 to the power of x. Now you can see here we don't have any subtraction or addition, so we cannot now take a common factor in this one. So we're not going to take a common factor in this one because there is no plus or minus between this term. This is just one big term. Also on the denominator you have one big term. So we have 45 now. We need to break down this 45 to become a small base. So I'm going to put 45 here. I'm going to say I need to divide now this 45 so that I can put it in the exponential form. So I'm going to take my calculator and then I'm going to say, okay, I want to divide this by 3, which is the smallest value. So I'm having something like 45 divided by 3, because 3 can go into 45 and will not leave a remainder. So I'm going to say 45 divided by 3. So I'll get something like 15. Then if I said 15 divided by 3, so it's 3, 6, 9, 12, 15, that is 5. So now 3 doesn't go into 5, so I'm going to say now 5 divided by 5, that will be a 1. So you can see there that I have 2 3's. So I have 3 to the power of 2 multiplied by 5. So 3 to the power of 2 multiplied by 5 is also equals to 45. So where I see 45, I'm going to put 3 to the power of 2 multiplied by a 5. That is also 45. Remember, outside we have that exponent, which is x plus 1. Multiply by 9. You know 9 is just 3 to the power of 2. Then outside I have that exponent, which is x minus 2. Then on my denominator, I have also a 9 again. So it's 3 to the power of 2. Outside I have the exponent 2x. Multiply this 5x. Now you can just leave it as 5x. Now we have this 2 that must multiply this x and that 1. So I have 3. The 2, which is the exponent of this 3, must multiply the exponents that are outside the bracket. So 2 times x, this is 2x. 2 times 1, that is a 2. multiplied by 5. Remember, there is a 1 here, which is an exponent of 5. So 1 times x is x. 1 times 1 is plus 1. Multiplied by, we have now this 2, which you must multiply by that x and multiplied by that 2. So 2 times x, we have a 3. 2 times x is 2x. 2 times negative 2 is negative 4. All over, yeah, we have to multiply these two exponents now. We have a base of 3. 2 times 2x is 4x. So this 2 times 2x is 4x multiplied by 5x. Then we continue. Remember, we have now two exponents. Okay, I think my laptop now is dying. Okay, I need to charge the battery, but let me quickly finish this one. Okay, I think the simpler way now from there, let us not expand this. Let's just take the base and add the exponents. So I'm going to say I have a base of 3. So I'm going to add this exponent to x plus 2. Then I'm going to go to this 3 here. I'm going to add that exponent, which is 2x minus 4. Now, you look now at the 3 that is in the denominator. This 3 that is on the denominator, I'm going to subtract now this exponent, which is negative 4x, times, I have a base of 5. So with the base of 5, the exponent is x plus 1. Then I'm going to look at the 5 that is on the denominator. This exponent now I have to subtract it. So we add the exponents where bases are the same. Then with the exponent that is in the denominator, we subtract it. For example, we subtracted this one because it's coming from this 3 that is in the denominator. We subtract this one because it's coming from the 5, which is on the denominator. So now I have a base of 3. Let me now put the sum of this 2x plus 2x, that is 4x, minus 4x, so it cancels out. 2 minus 4, so that means I have negative 2 here, times the 5. Let's add this one, x minus x, they cancel, they are left with the 1. So now we have something like, we can change now this to 1 over 3 squared times the 5. So that means that the 5 is on the numerator over 3 to the power of 2. Now 3 to the power of 2, you can put it as 9. So the answer is 5 over 9. Yeah, let me quickly stop this video, that I can charge the laptop. Yeah, so this is how you do the exponential expressions factorization, and also the one where you don't have to factorize. I'll see you now in the next video.